Okay, so here we have our output from SPSS, and as you can see, SPSS delights in giving us a lot of output. Don't worry about that though, because we'll show you the things that you need to focus on, the things that are important. So here are the descriptive statistics which we requested from one of the sub-menus. This just tells you the mean and standard deviation of each of the two variables, the outcome and the predictor variable, which is useful to have. Then we've got a correlation matrix here, and we can see that the two variables are related with a Pearson's correlation coefficient of 0.883, which is a strong positive correlation, which is what we predicted after we looked at the scatter plot. I wouldn't worry too much about the variables entered removed, because that tends to relate more to multiple linear regression. That's when we're adding more than one predictor variable to our regression model. The model summary is useful. You can see that this R is the same as the Pearson's correlation coefficient. Now the R square is also known as the coefficient of determination. This basically tells us whether how much variance in our outcome variable, so how much variance in our key stage 3 scores are explained by our predictor variable. Now 0.78 is the same as 78%, so that's 78% of all the variance in our key stage 3 score can be predicted from our key stage 2 score, which suggests that key stage 2 scores are a very, very good predictor. So this is a good sign for our model there. The ANOVA is just a way of testing whether our model's better than using just the mean to predict an outcome. So if this is statistically significant, which it is, that suggests that our model is a better predictor of the outcome than just using the mean. It's just a way of testing whether the model's worth anything, whether the model gives us anything more than just guessing at each time at the average score. And it does. It seems to be a good predictor. The coefficients will give us more information we need, and this is really useful because this tells us how to actually formulate our regression line. So we can plug these numbers into the formula and use that formula to predict a outcome variable when we know what our key stage 2 scores are. So the B value here under unstandardized coefficients for the constant, this is our intercept. So this is the point where key stage 2 score is 0, bearing in mind that the key stage 2 scores were centered, so 0 is the average. So when you get the average score on key stage 2, your score on key stage 3 will be 33.6. Perhaps more useful is the one below it for the KS2 average score. This is actually the gradient of the regression line. This basically means that for every 1 point increase you get at key stage 2, so if someone goes from a score of 0 to a score of 1 at key stage 2, they will go up 5.8 points on the key stage 3 score. So taking, again, someone going up from 0 to 1 on key stage 2, they'd go up from 33.6 to, or whatever it is, 39ish on key stage 3. The beta value there is a standardized version of this coefficient, and that's useful for when you multiple regression, really, because if you've got several predictors, then the standardized version will help you to see which one is the most important. Finally, this t-test is important because it will tell you whether the predictor is statistically significant, whether it's a statistically significant coefficient, and because this is less than 0.05, we can say that it is. The residual statistics will just tell us a little bit about just a summary of our residuals, really. So it tells you the minimum and maximum predicted values and the mean of the predicted values, and the same for the residuals. And it also gives us the standardized versions, where, as you can see, the mean's been changed to 0 there. So that's useful to sort of summarize the residuals overall and see how spread out they are. Now the best way to look at this, though, is the histogram which we requested. As you can see, the residuals seem to be normally distributed around the mean, which is a good sign because that's one of the assumptions of the regression. Finally, we have this. This is where we use the zpred and zresid functions on the plots submenu. we seem to have this problem down here with the floor effect, which again we might actually be able to weed out if we remove those cases where the minimum Key Stage 2 score was entered, because those cases just may be incomplete, the data may be incomplete. But generally we've got a fairly random distribution of scores there, so that's, I think, the assumption, we could say that the assumption has been met. So overall I think we can say that Key Stage 2 examination score is a good predictor of Key Stage 3 examination score, and we could build a reasonably good model that could help us predict Key Stage 3 scores when we have the students' Key Stage 2 scores. Okay, thanks very much.